Well, good morning. If this is working, then you can actually hear my voice and actually see me do this. And I kind of think I figured this out. And before I go on, I know I've had a few people respond back to me that struggled a little bit using coefficients as molecules. And the next thing we're going to do is use coefficients as moles. So before we go on, I kind of want to make sure that we know how to do this. And so, the first thing you actually have to do on all these is you have to balance the equation. And I'm not going to spend a lot of time doing that with you. You know how to do that. But for this equation, you need a 4 there, a 3 there, and a 2 there. And I want to go ahead and read what this actually says. This says that if you have 4 molecules of iron, it will react with 3 molecules of oxygen and give you 2 molecules of the iron oxide. And so we can look at those coefficients as being actually molecules, or sometimes formula units if it's ionic. And technically, the Fe2O3 would actually be formula units. All right, so question A says we want to know the number of molecules of O2 gas that combine with 24 molecules of Fe. Now you could probably actually just look at the ratio and the balanced equation and figure this out, but we're trying to do this using factor label because this is actually going to be one of our steps eventually when we get into the mass problems and the regular stoichiometry problems. But we always, if you remember, start with what we have and put it over 1. And so right here, I'm going to start with 24 molecules of iron, and I'm going to put it over 1. All right. Our next and actually only step we have left is do a molecule to molecule ratio. And what we're going to do is we're going to look at those coefficients as being molecules. So if you look into the equation, we have 4 molecules of iron, and we have 3 molecules of O2 to make this thing happen. Well, if iron's on top, and it is, that means this iron right here actually has to go on bottom. And so on bottom right now, we'll go with 4 molecules of iron, and from the balanced equation, 3 molecules of O2 on top. Now, I guess I could do it with a pen, but the molecules of iron cross off. There's one on top, one on bottom, so we have molecules of oxygen, which is what we're looking for. So now let's just do the math. And this one you can do in your head. 24 divided by 4 is 6, and 6 times 3 should be 18. And so the answer here is 18 molecules of O2. All right, let's try B. This time we're looking for the number of molecules of iron 3 oxide, which is this compound right here, that are formed from this many molecules of O2 and sufficient iron. Now I keep throwing that word sufficient iron, and you'll see that several times in these problems where it'll say sufficient this, sufficient this. All sufficient means is that you have enough. Because eventually we're going to get to these problems called limiting reactant problems, where you have to figure out which one of your reactants is the one you have the right amount of and which one you have too much of. So right now when you see sufficient, don't even worry about it. It just means you have enough of it to make it happen, and you have the right amount to make it happen. So again, we're going to start with what we have, which is this many molecules of O2, and we're going to put it over 1. All right, we are looking for iron 3 oxide, which is this compound right here. Well, again, if oxygen's on top, that means oxygen has to go on the bottom. And we're going to use the 3O2 because that's what my balanced equation says. So we'll go 3 molecules of O2 on bottom. And according to my balanced equation, that will give me 2 of the iron 3 oxide. And so that's going to go on top. All right, the molecules of O2 will cross off because you have one on top, one on bottom. And so now it's just a matter of doing the math. And so what you end up with is 6O2 times 10 to the 23rd divided by 3. And if you put that in a calculator, it should give you that right there. And that should be your answer right there. Although I didn't label it, did I? All right, C. This one says the number of molecules of iron left over if 200 molecules of iron are reacted with 120 molecules of O2. So right now we know we have too much iron. And so I've given you 2 numbers, and you have to decide which one to start with. And I'll just give you an example. If you have 4 pieces of bread and 1 piece of ham, would you agree that you can only make 1 sandwich? And I think you would agree with that because you only have 1 piece of ham. If you start with the 4 pieces of bread, then logic says you could make 2 sandwiches, but you don't have ham. You only have enough ham to make 1. And so you can never start with the one you have too much of. You always have to start with the one you have the right amount of. So we're not going to start with the iron, we're going to start with the oxygen. And then what we're going to do is we're going to figure out how much iron we should have used and then subtract to figure out how much is left over. So we're going to start with the 120 molecules. Oops, I didn't know where it was at. 120 molecules of O2. We're going to put it over 1. All right, we're still going back to the balanced equation. And from the balanced equation, it takes 3 molecules of O2 and it takes 4 molecules of iron. So the 3 molecules of O2 are going on the bottom and the 4 molecules of iron on top. And this one, again, you can do probably in your head without much math. But 120 divided by 3 is 40, and 40 times 4 is 160. Now, what we just figured out is how much iron we should have used. We didn't use that much. We used 200 molecules instead. And so if we want to know how much is left over, it's just simply subtract. So 200 minus 160 gives us 40 molecules of iron left over that we did not use. All right, last problem. It says the number of atoms of O2 that combine with sufficient iron to form 300 formula units of Fe2O3. All right, again, it says sufficient in there, and you don't have to worry about that. All that means is that we have enough. We have the right amount. So we're trying to figure out how many atoms, and this is a little bit different question because that O2 is actually a molecule. It's a molecule that contains 2 atoms. So this one has one little tiny extra step at the end, but not a big deal. So we're going to start with our 300 formula units of Fe2O3 and put it over 1. All right, and you can't see it right now. I have to scroll back up. But for my balanced equation, we're looking at Fe2O3 and the O2. From our balanced equation, it's 2 Fe2O3s and it's 3 O2s. Well, the Fe2O3 is on top, so that means it has to go on bottom. So we're going to go with 2 formula units, and ooh, I didn't label it again. Shame on Mr. Wallace, he didn't label that. That should say 2 formula units of Fe2O3, and that is 3 molecules of O2 on top. All right, the formula units cross off, and I end up with molecules, but I didn't actually ask for molecules. I asked for atoms. And so what we have to do, and we're not going to do this very much. This is just really for me to make sure you understand the difference between an atom and a molecule. But if you remember, atoms are the smallest part of elements that are still those elements, and molecules are the smallest part of compounds. We're going to say, well, in 1 molecule of O2, there is 2 atoms because of that little subscript right there. So one little tiny extra step you have to do. And we can do this one without a whole lot of math also. You got 2 on bottom and 2 on top. Those go away. And so basically all you have is 3 times 300, which is 900. So there's actually 900 atoms. And that's labeled wrong. That should just say O. I gotta fix some of this stuff. But 900 atoms of oxygen. Hopefully, for those, I know Jasmine was one of the ones that asked to see a video. Hopefully this helps you. Monday, I'm going to try to send out another paper that looks a lot like this, except this time, what I sent out Monday, instead of molecules, we're going to look at the coefficients as being moles, because that's a little bit more useful to us. But hopefully this helps. And again, always feel free to email me. I check my email periodically. I don't check it all. I don't sit around and look at it all the time, but I do check it periodically to make sure if you have any questions that I can try to answer. So hopefully that helps. All right. Y'all stay safe and be careful. All right. And hopefully we'll see you before too much longer. Bye.